In this video, we want to find the expression for the energy tensor for a frictionless adiabatic fluid. Now let P and ρ be two scalars, where P is the pressure, whereas ρ represents the density of the fluid. Let's define the contravariant symmetrical tensor T alpha beta like this: minus G alpha beta times P, the pressure, plus rho c squared plus P times derivative x alpha with respect to ds, derivative x beta with respect to ds. In special relativity, the tensor G mu nu can be written like this, using Einstein's convention, where the component 4, 4 here represents time. So we have minus 1 here for the 1, 1 component, minus 1 for the 2, 2 component, minus 1 for the 3, 3 component, and 1 for the 4, 4 component. So this is the time dimension according to Einstein's convention. Then we have all zeros here. Let me just write them down. And now if also dx alpha over ds is equal to 0, 0, 0, 1, and this basically means that the three-dimensional velocity is 0 here, and we are in static conditions, this expression can be written like this: T alpha beta equal to P times the tensor 1, 1, 1, minus 1, and all zeros out of the diagonal, like this. Then we have plus rho c squared plus P times a very simple matrix with all zeros, and the only non-zero entry is the 4, 4 entry. So here we have all zeros except for this 4, 4 entry, which is equal to 1. So if we put these tensors together, we get just one tensor, or one matrix if you want. P, P, P on the diagonal, and then the 4, 4 entry is rho c squared, like this, and zeros out of the diagonal here, like this. So this tensor here, this matrix, is the energy momentum tensor for a frictionless adiabatic fluid in static conditions, because you see that the fluid is described only by the pressure and only the energy density here. Now we can consider this general expression together with the equations that we have already found in general relativity. So let me write some equations down. We have derivative T alpha sigma with respect to x alpha. We found this to be equal to minus gamma beta alpha sigma times T alpha beta. Then we can rewrite the expression above for the energy tensor, in this case for this fluid, with mixed indices. So with mixed indices, this becomes T alpha sigma equal to minus delta alpha sigma times P plus rho c squared plus P times dx alpha ds dx beta over ds times G beta sigma, like this. So let me call this equation 1, this is equation 2. Then we have other equations. So we have square root of minus g equal to 1. It's another condition that we have imposed upon our coordinate system. Then we also have g alpha beta times dx alpha over ds dx beta over ds equal to 1, which is equation 4. And we also have another equation, equation 5, which is a relation between the density of the fluid and its pressure. So we have another equation characterizing the density with respect to pressure, or also vice versa. We could also find the pressure from the density. It's just an equation of the fluid. So I assume that it can take this form, and it's equation 5. Now, if the tensor g mu nu is given, so if we have the metric tensor, we can consider only equations 1, 2, 4, and 5. So we can disregard this one. And these equations, 1, 2, 4, and 5, consist in 6 scalar equations, because we have 4 equations here, and we have to put these two together. So let's assume that we put 1 and 2 together. So 1 and 2 together make 4 equations, 4 scalar equations, whereas 4 and 5 give me another 2 equations, so we have all in all 6 equations. And what are the unknowns? The unknowns are p, rho, then we have dx1 over ds, dx2 over ds, dx3 over ds, and dx4 over ds. So in this case, we have 6 equations and 6 unknowns, and we can solve the problem. But now let's assume that g mu nu is unknown. So we have another 10 components to be found, because g mu nu is a symmetric tensor, a symmetric 4x4 tensor. So we have another 10 components to be found. Also remember that we have another equation, which is this one that we have derived in previous videos. We have d gamma alpha mu nu with respect to x alpha plus gamma alpha mu beta times gamma beta mu alpha equal to minus k t mu nu minus 1/2 g mu nu times t. Now this equation here already contains equation 1. So if we consider this equation, we cannot consider 1 to be independent. So this equation here should be disregarded in this case. So together with the equations 3, 4, and 5, if we put this one together with the second one here, how many scalar equations do we have? Well, we have 13 equations if you count them, because we have 10 equations from here, then we have 11, one additional equation from here, so 10 plus 1, 11, another one, 12, another one, 13. So we have 13 scalar equations. How many are the unknowns? Well, the unknowns are 16, because we have 10 independent components of g mu nu, but we also have these components here. So we have 16 components, 16 unknowns, but only 13 equations. So you might think that we have a problem here because we cannot solve this system of equations. However, there is a good reason for this lack of definition due to the wide freedom of choice of the coordinates, which caused the problem to remain mathematically undefined to such a degree that 3 of the functions of space may be chosen at will. So we can choose 3 of these functions at will. Why can we do that? Well, let's also consider this fact. We have imposed this condition, square root of minus g equal to 1. But we can also remove that condition. We can abandon that choice of coordinates. So if we abandon this choice, we not only we have 3 degrees of freedom in the choice of the g mu nu, but we have 4. because we are going to remove another condition from here. So we have 4 functions of space that can be chosen at will. We have such liberty of choice. But this simply corresponds exactly to the 4 arbitrary functions at our disposal in the choice of coordinates. So this number 4 comes from the fact that we can choose any coordinate system. So we have another 4 degrees of freedom. And with those degrees of freedom in mind, we can solve also, in principle, we can solve also this system here, this more general system where we have to find also the g mu nu.